an overview of Apache Log4J. So it's time to understand what all the fuss is. Now, in order to do that, we really need to understand what Log4j is. So what is Log4j? Well, it's a Java-based logging utility, and it's part of that Apache logging services. In fact, Log4j is one of many Java logging services and is used everywhere. Now, there's multiple versions of Log4j. The current version is Log4j version 2, which is an updated version of Log4j version 1. And this improves on reliability, extensibility, simplifies config syntax, leverages multiple APIs, and improves speed and more. Now, it logs items such as security and performance information, and multiple external resources suggest upwards of 3 billion devices leverage Java. I mean, Oracle states that there is as many as 13 billion devices that are leveraging it as well. So we could be exposed to 3 billion plus devices with this particular vulnerability. Now, Java is leveraged in a variety of consumer and enterprise applications, services, and websites. It's not operating system dependent, and even critical devices such as medical devices may also be at risk. So there's certainly an opportunity here if there was a vulnerability, and in this case, there is. So the other piece of this is JNDI. So what is JNDI? Well, it's Java Naming and Directory Interface, and it's an application programming interface which provides the ability to associate a name to an object, creating a binding. Now think of DNS. DNS is domain name service, and it provides the translation between a name and an IP address. So someone goes to a web browser, types in www.something.com, it translates this into an IP address, and then this is the location where your service is going to be. And your network understands IP addressing. It's very similar to user to IP address mapping as well. Because what happens on a next-gen firewall, as an example, is that you can build policy based on usernames or identity, but the network doesn't understand identity. And therefore, you need to translate that to the IP address that the user or device is connecting from. And once you do that, then you can enforce based on that IP address. Directory lookups that provide general queries. So this can be remote or local. And there's services such as LDAP, DNS, NIS, NDS, RMI, Cobra, and more maybe, right? So there's no real limitation there. Those are just some of the core services being offered. And we'll talk a little bit more of those services as we move along. And these services are leveraged using what they call as the Java Service Provider Interface. So JNDI SPI. So what does this look like? Well, you've got the Java application. And here you have the JNDI Application Programming Interface. Then we've got this naming manager. And there we have the Service Provider Interface. And ultimately the services themselves. So LDAP, DNS, NIS, NDS, RMI, and Cobra. So applications use JNDI to access resources and learn their locations. Now, this enables developers more flexibility and removes the need to hard code locations or maintain configuration files. So we all know this, that any time that you must maintain hard-coded settings or configuration files, the operational burden is higher due to changes, especially if they're dynamic to the environment, and increases the risk of impact. Anytime that you do this, it might mean that you need to recompile code and upload and update systems. And obviously there's risks anytime you do that, as well as changing configuration files, especially manually, is prone to error. So if resources, as an example, shift to a new server with a new IP address, JNDI updates the binding and it's done. So that's the advantage of leveraging JNDI. Now we've got some concerns, and our concerns are really, at least in this course, is focused on LDAP, DNS, and RMI. So what are some example use cases? Well, we're going to focus on LDAP. LDAP is going to be the primary use case here. Now, LDAP can be used to simply enrich log files with dynamic data or look up additional services, and this could be on a local machine or a remote system. Now, other SPI services have also provided fruits for the adversary, one of which is RMI, Remote Method Invocation, which allows an object to invoke a method on another object in another address space, which can be on another machine. And then you have DNS, which provides the ability to look up names and map to an IP address. Now, we'll talk a little bit more specifically as we move along how the adversary is going to leverage these services. So what is some of the data that would be logged? Well, if you had a web front end, you might want to capture the HTTP headers. Why? Well, it's going to give us insight into the request method. The request method in this case is GET. Somebody's trying to get something from the web page. The request URI. This is the location, the actual location on the web service of the request itself. You've got the request version and lots of other data that's being captured here. And again, this is going to help the developer or somebody that's troubleshooting understand how the client may be connecting. User agents. This is going to show us the browser in which the user is connecting from. So as an example, it could be a Windows-based system running Edge versus a Linux-based system running Firefox. It could be a mobile device running Safari. All of this information, again, is going to be helpful, especially if the user is experiencing a different behavior. But on some systems, it's fine, and other systems, it's not. And this is going to help us identify that. Refer. This is, in fact, a field that's optional that identifies the address of the web page from which the resource has been requested. So, for example, if you are on site A and you click a link on site A and it goes to example.com, that's the refer. So we're going to capture that information of that site that you were previously at, that you've made the connection or was referred to, and that gives us insight into where you were. Now, X-forwarded for, this captures the client requesting IP address. So you might think, well, what's the big deal here? It should capture the IP address it's making the connection. Well, it may not be, right? There could be a proxy that's in the middle of this connection. And so what a proxy does, it's an intermediary where the client and server never actually communicate with each other. And then you can run additional security services on that device. Now, what the web server is going to see is actually the proxy IP address and not the client requesting IP address. X-forwarded for, if it's turned on the proxy, we capture the client requesting IP address, stitch it in, and now it's available for the web service to identify the requester, the actual client making the request itself. Again, all helpful. You can think of this from a troubleshooting perspective, or it could also be from a security perspective. For example, if a user agent has issues with the user agent and causes risk to the web service, or the requesting client IP address is coming from an adversary that's known, all of that is good insight. Data matters, and that's why logging is important. So let's look at some examples here. So why would anybody turn on JNDI logging? Well, previously to any patching that you may have done, the default configuration was enabled. So that's part of the problem. It's part of that default config. But you also may leverage it to enhance logging with path or prefix data. And so an example might be something as simple as this, right? You have a string that says, a severe error. And so you've got this string that's going to give this log message of a severe error. But you want to enrich it. So at the bottom here, you've got log.error, and then it's calling out this variable endpoint LDAP. And then you've got that issue occurred, and then the variable error message, which is going to be a server error. That variable that's in red here is going to reach out to the LDAP server. This is going to use that JNDI service, and they're going to reach out to LDAP to figure out who endpoint LDAP is. And so that'll make the request to the LDAP services, and it's going to use the JNDI service provider interface, right? That API that's going to, tie all of this together. And it's going to leverage LDAP, and it's going to ask it, what is that endpoint LDAP? Can you let me know what that is? And so that query is made to that remote system. Most likely, it's not going to be the system in which the service is being offered. And then it's going to do that lookup, and it's going to provide that response. So in this case, endpoint A, and now you can see my log message is a little bit more informational, right? It says there's an error, but it's telling me which endpoint it is. So I've got additional context here. And then it's adding issue occurred. And then now that variable message that says a severe error has occurred. So that's kind of the use case, or a very simple use case. It could be leveraging services in the back end. So it's doing the lookup for that additional service, the location of that service, and providing that information back to the requester. So what's the big deal? How can something so simple like logging be so dangerous? Well, a vulnerability was discovered, which allows an unauthenticated remote actor an opportunity to exploit and take control of a targeted system. So there's billions of devices that have this default configuration, which enables JNDI. And logs captured using Log4J and leverage JNDI lookups, which in fact are passed to LDAP in this example, are crafted to execute arbitrary code. So what is the level of risk? How severe is it? Well, it's high risk, the highest that you can possibly get. And this requires immediate attention, like patching. That should be your go-to. You want to patch this immediately if possible. Ease of exploit also makes this high risk, right? It's remotely accessible. All they have to do is craft a request in a manner of which can run this arbitrary code on that system. And how common is it? Well, that's another big problem here, right? There's billions of devices that are impacted by this vulnerability. So what is the adversary's opportunity here, really? Well, the adversary can leverage the exploit in many different ways. They can gain control of the system. Obviously, that's bad, right? They can call back to command and control. They can install software. They can run miners, right? Crypto miners. You can launch ransomware. You can steal information. So using something like DNS might provide you some additional insight. You can move laterally within the environment from that asset. You can establish a remote shell. You have the ability to do mass scanning and perform reconnaissance. There's all kinds of malicious activity available to the adversary. If they can execute that code on that system, the opportunities are limitless. And therefore, again, this risk level with this particular vulnerability is significantly high. And I know that many of you have already addressed this, but we continue to see vulnerabilities exposed with this system. Coming up next, insight into the vulnerability.